When I got this machine over 10 years ago now, it took me a few months to figure out how to use it, and Daniel over at the D&J Machining channel, I'll put a link to his channel in the description below, he's recently acquired a similar vintage Arberg and is going through the pangs of learning how to use the thing, so he's been picking my brains for a bit of assistance and has suggested I give a bit of a walk around on this machine so that we can have a look at exactly what all the different parts are, what everything is called, how it all works, and basically the sort of things that you need to know about if you're going to try and get one of these up and running. And I will apologise in advance if some of this video is a bit wobbly because I'm having to film it by hand on account of the fact that it's kind of difficult to get in to all of the different areas with a tripod, so we'll just see how we get on. This is the main control cabinet. On some machines they're integrated into the main body, but on this particular machine it's a separate module, so it's basically just a rather large cabinet with a load of circuit boards in. The most important one, well they're all quite important, but the most important one is this here, which is the main processor board. It's actually running on an old 8086 to show it's vintage, and below it we have the video card. On machines this old, the cards do age and overheat a little bit, so I've actually had to stick some heat sinks and some fans on here just to stop it from overheating. Classic telltale sign of that is if your screen starts to play up and start showing random characters and gibberish, and if the machine just basically conks out every once in a while. If it works on a cold start, then it could well be an overheating board. That all plugs into main back frame. And then along here we have up to 20 cards which control all of the different features. See if I can adjust the exposure to get slightly more brightness on that. I don't know if it's working, but these all have different jobs to do. This is a second processor. This one I think handles, what does that one handle? I think that's the cooling system and a few other bits and bobs, and then most of these control the different cycle features of the machine itself. Over here there is a separate board which I have fixed in the past, and if I can get a slightly better lighting on it, this is the heater control card. So there's basically 6 solid state relays in here and a circuit board controlling them all. I did have to replace a couple of transistors up here a while ago. In fact I think I did these as well because they didn't put any provision for induced EMF. If the power goes off you can get a spike induced through these inductive couplers, and that blew some of the transistors, so that wasn't a great design. The rest of this is just the breakers for all the control gear and some contactors. I did replace one of these contactors recently. They're pretty much the same as relays. They're quite expensive actually, but you don't technically need a contactor. They are the preferred way to go, but a standard relay will do the job as well, and these are obviously 3-phase for this machine. And then there's just some cooling systems down the bottom, so it's kind of looks messy, but to be honest it's hooked up, there we go, but to be honest it's not that bad, especially if you've got a service manual, and the fact that all of this is through-hole technology gives you a sporting chance of fixing things when it goes wrong. So the machine itself, the plastic comes in here and down into the main barrel assembly. I did used to have a proper hopper loader, but I very rarely used it and it was taking up space. The sort of short runs that I do, I don't really need to be loading 25 kilos into a hopper every time. So down here there's actually a kitchen funnel which is fine for sort of half-kilo doses, and I just keep topping that up as necessary. But obviously you can get a proper hopper loader on there if necessary. That feeds down into the barrel assembly, which is along here with the nozzle at the end, which connects with the mould that's over there. Inside here is obviously the long screw that acts as an auger to pump the plastic along, big hydraulic pump at this end to turn the screw, and then some hydraulic rams to inject once the plastic has been dosed to the required level. Down here is something that I've fixed recently. This is the cooling manifold with all the hoses coming out. This is actually a nightmare to service. Why Arberg didn't just buy some off the shelf control valves I don't know, but they decided to reinvent the wheel and make their own from scratch. and taking these things apart is a bit of a nuisance if you get a problem. Underneath each of these caps there's a control circuit and then a kind of clockwork mechanism running off a stepper motor, and then that turns a small cam in there which basically opens and closes the valves. So on the front here we have the red return lines because the water is hot coming out, it's a cooling system, and on the back there are equivalent black nozzles where the cooling goes in. So there's a main feed on the top here, and then it's distributed out to all the cooling systems as necessary. You don't need all of these. I've got 4 on here which are actually cooling the mould, but you only really need that if you're doing a long run and your mould starts getting a little bit too hot and causing problems. The other 3 at the front, one does the oil through the oil filter, which is over there. One cools the control cabinet, which is to my left, and the other one controls the feed yoke, which is where the plastic goes in. That sometimes can be problematic with some materials because if it gets too hot up here, your granules start melting in the throat and then they won't feed properly. But generally speaking, you don't really need a cooling system to do fairly, modest run jobs for an hour or two, and even then you probably get away with it for a little while longer. Moving down a little bit, this is the injection distribution unit, and again it's all old school through-hole componentry. Most of the wires are labelled, and if you've got a copy of the service manual that helps because you can sort of trace out what's going on. There's a DC to DC converter at the back there, and then these 3 cards are the main analog cards for controlling the 3 things that happen at the injection end. So basically that's the dosage will be one of the cards, the second card will be handling the injection, and the third card moves the whole barrel assembly back and forth, because if you need to purge it out you can't have the nozzle against the mould itself. You need to bring that back a little bit, and then you can squirt out any plastic that's in there that you don't need before you go on to the next material. So they're the 3 activities that take place at the injection end: barrel back and forth, the nozzle back and forth, mostly forth to do the injection, and obviously turning the screw. So these 3 cards, technically they need to be calibrated slightly for the machine, and there's some little adjustment potentiometers on there. I have had one of these die on me before. I did manage to figure out what it was, but I think it had done some other damage and I couldn't quite recover the card. But you can still find these if you hunt around. There's a guy in Germany who breaks down old machines, I think, and sells off the parts. So I got a spare card for about 150 quid delivered. Wasn't the end of the world. But nothing terribly sophisticated, to be honest. It looks very complicated, but it's basically a load of op amps that are just doing various control signals. Over here we have an optional extra, if you like. This is basically just a garden water butt, and what's going on here is I've basically used hoses that are far too long for what I actually need, but by coiling the hoses into here and filling this with water, this acts as a heat sink. So it basically takes some of the pressure off the chiller, which does most of the cooling. So instead of the cooling system having to work to keep everything cool, I've got this as a reservoir which just helps keep all of the water in the system cool, and that just buys me a little bit more time before the chiller kicks in and starts wasting electricity. But you don't really need these, but I think a few moulders use similar systems, to be honest. Some at the bigger mould shops just have cold water running around the whole building and just plug in as required. Some systems also have mould heaters. I don't have any provision for heating the mould, I just have to let it warm up naturally. But some materials definitely process better if the mould is warm, otherwise you can get short shots at startup and various other issues. But pumping 200 degrees plastic into a mould, even though it can be quite a large chunk of steel, doesn't really take that long to warm it up, sort of 20 minutes or so. So mostly it's about cooling rather than heating, but even so you don't really need all of this. Moving slightly further down the machine, we have another sub-distributor unit, and this is only populated with 2 cards, and these 2 cards control the clamping side. So basically one of these controls moving the moving half backwards and forwards and doing the clamp, and the other one is the ejectors. I don't actually use the ejector system, but it won't work without it because it's a standard configuration. The remaining slots are for other peripherals that you might want to add, such as a core pull and things like this, but they're not needed for the kind of thing that I do. So this side is relatively straightforward, and I think those cards are pretty much identical but again, they're supposed to be calibrated, so I don't mess with those too much. And then here, I don't even know if it's visible in this light. Maybe if I turn the exposure up slightly. This is one of the main manifolds for the hydraulics. There's another one in the other distribution system over there, and this is all the hydraulic systems for opening and closing the mould and doing the ejectors forwards and backwards. So it's all fairly modular system at the end of the day. But if any of these parts go wrong, unfortunately so far they haven't, touch wood, but they can be quite expensive. You can be looking for a couple of £100 to replace one of those, plus a rather messy job stripping it all down. This machine also has a conveyor belt system which currently doesn't work. That's actually these two nozzles here. I don't really use it, so I've never gotten around to fixing it, but it does have a provision for a conveyor belt underneath should you need that kind of system on your machine. This is the chiller unit, which sits right at the end of the machine. This is a single phase machine, and second hand these still go for a few £100 to be honest, which is quite a lot considering it's just a glorified fridge and a pump. The bigger three-phase ones can go for several thousand, even second hand, but essentially all this is doing is just taking water, cooling it, and then pumping it around that system, and the control manifold, which I showed you over that side, that actually regulates where the water goes. So this is just the heart that pumps the water around. All of the actual control, temperature control and stuff like that is done on that water manifold at the far end. There's thermocouples in there, and despite the elaborate system that Arburg have used to implement it, it does work reasonably well. So you can keep the moulds at a particular temperature, the oil at a particular temperature, the feed yolk at a particular temperature, and it's a relatively straightforward plumbing job, although having it running right next door to a load of electrics is not particularly inspiring confidence, but so far so good. You do occasionally get leaks out of things like this, but this is really an ancillary part that you don't need to get started. In fact, it was probably a long while before I actually got around to plumbing all this in. On the front of the machine, which you will have seen many times if you've seen some of my other videos, we've got the main control panel in the centre with the all-important emergency stop. Thump this and everything switches off immediately. I did do a video recently showing roughly what all of these buttons do. You've got mould backwards, mould forwards, so open, close. That will also clamp. You've got the barrel assembly forwards and backwards, and the screw forwards and backwards, and then the dosing button. That's the ejectors forwards and backwards, which I don't use on this system. Motor on and off, heaters on and off. This button here is quite important because you use that for zeroing everything. So you close the mould, hold that button down and press that one as well, and likewise you need to zero the barrel so that it knows it's connected with the mould, and the ejectors. All three of these systems, the ejectors, the mould and the barrel, they can all be at slightly different distances depending on the mould that is actually in the machine, so you do need a zeroing point to tell the machine where you're at. This switch here just sets up different operating modes. You've got a warm-up mode and a dry cycle mode and a host processor mode. This is the reset start-stop button, and this is manual semi-automatic. The doors on old moulding machines tend to fail at the catches, and this one is no different, so you have to push the thing right the way back to engage the safety interlock before the machine will work. If you try and just close it arbitrarily and press play, the machine will sometimes flag an error, but it's easy to fix. You just slam the door backwards and forwards again, and this is a pretty common fault, to be honest. If you open this door while the machine is running, or the guard on the top or the guard on the right, it will again shut down immediately, just as if you had hit the emergency stop button. Back to shaky hand cam, and this is the mould base that I use. These platens don't fully close against the bulkhead on this side, so this is the fixed half. This is just the main plate which everything clamps against in the machine. This one is on the hydraulics and will move backwards and forwards, and there is a minimum separation between these two called the minimum daylight, and your mould needs to be at least that big in order to clamp fully against it. The mould itself is just held in with some clamps. These aren't bolted into the machine. It's surprising how just a little bit of sideways pressure will actually hold several tons in some cases of steel into a mould, just pressing against the surface. You can also clamp them by using bolts if necessary, but then it becomes harder to change them out. These are the main tie bars on which the moving platen slides back and forth, so there's one top and bottom and two on the other side. Up here we've got the cooling, which just goes in through the mould. There's a long hole drilled all the way down, and then at the bottom there is a loop which comes back up. So we've got an in and an out on the fixed half, and an in and an out on the moving half. And then down here, this shape here, which you might just be able to see, this is the ejector. So this actually moves back and forth, and there is a little bolt here. Well, it looks like a bolt. Actually, you do a quarter turn there, and that releases the pin, which then connects to the ejector mechanism in the mould. If you're not using an ejector system, then you can obviously take this out, but occasionally I run the original mould, which does have provision for ejectors. Most of the moulds that I use don't. I just peel stuff out of the mould as necessary. So this is the ejector thing, which just moves back and forth. Up here there is a linear encoder which allows it to read the position, and somewhere buried behind the back there will be a similar encoder for measuring the position of this mould. And obviously once you've set the 0 point, the machine knows the distance of your mould, the mould height as it's called, and can basically work out how far back and forward you're travelling. One thing that did catch me out when I first got this machine, you'll notice here that there's a little tiny lip. Well, this actually used to hang out quite a lot more. These are the clamping plates that go on the back of the mould on either side, so there's one there and one here as well. And when you buy a mould, it's actually the distance of this that is specified, not the distance of the clamping plates. So of course I ordered the mould, and then to my horror discovered that the clamping plates were about 2 inches too wide, and all this had to be machined off so I could fit it into the machine. And then I had to cut some slots in the side so my clamps would go in. So that was a bit of a nuisance when I first started out, but lesson learned. So moulds are generally specified by the width and the height, and I think they're, in the UK at least, they're all rounded to the nearest 4 millimeters. It's either you'd get like 100, I don't know if it's 194 or 196, but for some reason it's not 200, and then you would get 246 instead of 250, and I don't really know where that comes from, but that's how they're specified. And then obviously you've got the mould height as well. If I come over the top and move the light out of the way, we can see here this is the moving ejector plate. I'd probably have to open the mould to show this in more detail, so maybe a follow-up video at some point on that. But there's some guide pins here where the thing slides back and forth, and then attached to this will be various pins going right the way through the moving half of the mould to actually knock items out when the mould opens. A feature on my machine which is, well, it's sort of standard, but you don't always get it, but this is a hot runner controller, which is the subject of a whole nother video, but this is just a legacy of the mould that I'm using. Simple moulds don't really do that. They just have a main feed going through the middle. When the mould opens, there's a little sprue which you pull out, and that gets reground or discarded. The point of a hot runner system like this is it provides additional feed points into the mould, and inside here there is a heated manifold which splits the plastic into 2 channels, so it comes in at the back, goes top and bottom in a heated manifold, and then there's 2 hot tips, top and bottom, which actually feed into the mould. But it's a complicated subject, and maybe I'll do a video on that at some point. And the final section is the injection side. This is probably the most important part of the moulding process. This is where the magic happens. The clamping unit is really just a hydraulic clamp. It doesn't really matter too much how quickly that moves or how accurately it moves. As long as it shuts fully and then clamps with a lot of force, you're good to go. But this needs to be pretty accurate. The amount of material that you dose needs to be accurate. The injection speeds and pressures need to be accurate. And underneath here there are 6 heaters, and well, 4 under there and 2 more at the front. And if I can get in a little closer, you can perhaps see, I'll show a separate mould actually of how this works, but the nozzle connects to the back of the mould, which is where the plastic is fed in, and obviously there's a hole through there which goes through to the face plates. And then over here, for completeness, although I've done a video on all of this separately, this is the programming system on this machine. The original screen died and they're a nightmare to get replacements, but you can get these XVGA converter boxes which basically take the incoming signals for the original monitor and pipe it out as a standard VGA computer signal, which then you can just plug into any old monitor to get your screen back. But up here we have the control buttons over this side, if I can point correctly. These are ancillary functions, and then over here these are the main functions that you have, setting the speeds for the mould opening and closing and so on, and then just a number pad down here for typing everything in. But you'll have to watch the other video if you want more details on exactly how all that works. Two other important aspects of the moulding process. These are called grid magnets, and basically you drop these into your hopper, so if any metal swarf comes through, assuming it's ferrous, it will stick to the magnet rather than going through into the machine itself, which can cause a whole lot of problems. Can't do a lot about aluminium and brass, unfortunately, so you just have to be careful you don't get anything contaminated in your plastic. And grit is also a major issue. You don't want plastic granules spilling on the floor, sweeping them up and chucking them in your machine, because you've only got to have one little tiny speck of grit, and that can block everything and require you to strip the whole machine down to clear it out. But grid magnets are fairly standard, and the other stuff that you almost certainly need is some silicone spray. You can get proper mould release, but they charge you extra for it, but just standard silicone spray, and you squirt a bit of that on your mould, and then when you're moulding it makes it easier to get the parts out. Another useful piece of equipment to have is a drying oven. This is quite a large freestanding unit. Obviously you don't need anything quite this big. You could get away with something, you know, sort of that size. You just need to get up to about 100 degrees for a couple of hours to dry your plastic out. This one just uses simple trays, and I stick maybe a couple of kilograms of granules on there and leave them in the oven for a couple of hours just to get the moisture out. Some materials are notoriously bad for picking up moisture, nylon and polyurethanes in particular. Other materials like polyethylene, polypropylene, doesn't really matter, you can just mould them as is. Very good materials to start out playing with, because you can't really go wrong with the stuff. It's not the greatest material, but it is fairly cheap and forgiving. But an oven is certainly a useful thing to have should you start working with some more exotic materials. And although I'm not going to go into too much detail, this is another mould which is kind of buried under a pile of parts, but this is the fixed half. This stuff literally weighs over a ton, so it's difficult to move around and show you exactly what's inside, but the hole at the back is where the injection nozzle will connect. There's then what's called a seating ring, or locating ring, which basically bolts onto that hole, and then you use that to install the mould in the machine, and the nozzle connects at the back there, and going into the mould there will be a sprue with sometimes a small radius on the back, so the nozzle connects to that and it goes straight the way through and into the mould. This system, if I can spin the camera a little bit, this is a hot runner. These are horrendously expensive to be commissioned, but basically this has got heaters snaking the way around it, and there's a main inlet at the centre, and then along the top here on one side there are 12 outlets where a little heated nozzle like this will connect, and this will have a heater and a thermocouple, and then the plastic comes out through the tip and actually into the mould. This is a more efficient way of moulding, but they are horrendously expensive to make these, and they can cause a few problems as well. I haven't got a smaller mould I can strip down to show all the components, unfortunately, but this is quite a small mould as things go. I've seen machines running moulds that are 10 times the size of this, and God only knows how much they cost. And to conclude this whistle stop tour, I think I've shown this in other videos. I'll probably do a full video showing what's inside this and how it works, but this is a granulator, not a shredder. Shredding is for paper and garden waste. In plastic we work with granules, so all of your old material goes in there, anything that's a duff part, or the runners and sprues and so on, anything that you can basically recycle and reuse, you chuck it in there. Towards the bottom is a rotating drum, which I'll take this thing apart and show you what's in it in another video at some point, and that just shreds everything into tiny little granules which come out here. If you put in bottles and things, you'll get flakes coming out which aren't so good. What you really want are granules, hence the name granulator. These are quite expensive. You can get smaller ones for a few £100, and I dare say a garden shredder might just work as a last resort. But if you're getting through a lot of plastic, then certainly you don't want to be throwing it away, putting it in the landfill. If you can chop it up and reuse it again, then one of these will pay for itself in not too much time. But I think you can get smaller ones for these, which are just light garden shredders with a throat hopper on the top, and I think they're a few £100 probably, and there are designs on the internet for making your own. Something this size is a little bit more expensive. In fact, this wasn't the one I was supposed to get. They put the wrong one on the delivery lorry, but they can be bothered to take it back, so I ended up with it. And this will chop up things the size of your fist without too much difficulty. When you're working with these machines, you take off your watch and any jewellery, because if it goes in, it is not coming back. It's quite a beast of a machine really, and it makes a horrible racket, but I will probably do a video showing what's inside that at a later stage, because I did have a couple of students come over end of last year, I think, who were inquiring about what goes on inside one of these, so if they were interested, I'm sure maybe other people are as well. But anyway, that's a whistle-stop tour of the injection moulding process and the bits that go together to make the system work. I could do probably with finding a mould I can strip down to show what's inside that, but that'll have to wait for a later day. So anyway, if you've got any other questions, let me know, and I will follow it up as appropriate.